Today we will do forces between multiple charges, and we will discuss also the superposition principle. The statement of superposition principle states that force on any charge due to a number of other charges is the vector sum of all the forces on that charge due to the other charges, taken one at a time. The individual forces are unaffected due to the presence of the other charges. It means that if we have a system of n numbers of charges, let us say Q1, Q2 up to Qn, then suppose we want to find the force on Q1 due to the other charges Q2, Q3 up to Qn, then first we will find the force between Q1 and Q2, then the force between Q1 and Q3, and so on up to the force between Q1 and Qn. Then we will add all these forces to get the total force acting on Q1. That is, we can say F1, the total force which is acting on Q1, so it will be equal to F12 force on Q1 due to Q2 plus F13 force on Q1 due to Q3 plus dot 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 plus up to force on Q1 due to Qn, F1n. Now also the force between charge Q1 and charge Q2 will not be affected due to the presence of other charges Q3, Q4 up to Qn. Similarly, the force between charge Q1 and Q3 will not be affected by the presence of the charge Q2, Q4 and up to Qn. Now let us consider a system having three charges, like we have seen in this diagram, figure 1. So we consider a system of three charges, Q1, Q2 and Q3. We also have seen that Q1 has a position vector R1 from O, Q2 has a position vector R2 from O, Q3 has a position vector R3 from O, and also a unit vector R12 pointing from Q2 to Q1, and a unit vector R13 pointing from Q3 to Q1. We have a force between Q1 and Q2 denoted by F12, and a force between Q1 and Q3 denoted by F13. Now if we want to get the total force which is acting at Q1, we have to add the force F12 and the force F13 by parallelogram law of vector addition. So if we do that, if we add F12 and F13 by parallelogram law of vector addition, we get the resultant force F1. So the force F1 is the total force which is acting on Q1. So let us write it. So we can say here if you can drop this, if the force on Q1 due to Q2 is denoted by F12, then by Coulomb's law, we have F12 will be equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 square R12 cap. Name this as equation number 1. Similarly, we can write in the same way the force on Q1 due to Q3 is denoted by F13 is given by F13 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 square. Oh, here it will be Q3, not Q2. So it is Q1 Q3 by R13 square R13 cap. Name this as equation number 2. Now the total force we can write here. Does the total force F1 on Q1 due to the other two charges Q2 and Q3 is given by F1, which is equal to F12 plus F13. If we substitute the value F12 and F13 here, so, or we can say here F1 will be equal to, substitute the value F12, so it will be 1 by 4 pi epsilon naught Q1 Q2 by R12 square R12 cap plus 1 by 4 pi epsilon naught Q1 Q3 R13 square R13 cap. Name this as equation number 3. So equation 3 is the required equation. Equation 3 is the required equation for a system of three charges Q1, Q2 and Q3. So if the system has only 3 charges, so equation 3 is the required equation. But sometimes the number of charges will not be only 3, but it is let us say up to n number of charges. So in that case, equation 3 can be generalized to a system of charges more than 3, as shown in the figure number 2 here. So in this figure, so here in this figure we have seen that there are n number of charges Q1, Q2, Q3 up to Qn. Q1 is at a position vector R1 from O, Q2 is at a position vector R2 from O, and Q3 is at a position vector R3 from O, and Qn is at a position vector Rn from O. Now the force between Q1 and Q2 is given by F12, force between Q1 and Q3 is given by F13, and the force between Q1 and Qn is given by F1n. So here also, if we want to get the total force which is acting on Q1, first of all we have to add two force at a time. So for example, if we add the force F12 and F13, we will get the resultant force which I mark with the green arrow here. This is the resultant force between F12 and F13. So we have to add F12 and F13 by parallelogram law of vector addition, so we will get the resultant force. So we have to continue the process of addition two forces at a time. So finally we will get, for example, in this case, the force F1 here. So the force F1 is the total force which is acting on Q1 due to the n number of charges, let us say due to Q2, Q3 up to Qn. Now the principle of superposition says that in a system of charges Q1, Q2 up to Qn, the force on Q1 due to Q2 is the same as given by Coulomb's law. That is, it is unaffected by the presence of the other charges Q3, Q4 up to Qn. The total force F1, we can write the total force F1 the total force F1 on charge Q1 due to all other charges is given by the vector sum of the forces F12, F13, up to F1n. That is, we can write, that is, F1 will be equal to F12 plus F13 plus plus F1n. Now we will substitute the value of F1 to F13 up to F1n, so we will get the final answer. So we will do it this side. So okay, so we will substitute the force, or we can write here F1 will be equal to the force F12, so it will be 1 by 4 pi epsilon naught Q1 Q2 by R12 square R12 cap plus F13, so it will be 1 by 4 pi epsilon naught Q1 Q3 R13 square R13 cap plus plus 1 by 4 pi epsilon naught Q1 Qn R1n square R1n cap. So here we have seen that the value 1 by 4 pi epsilon naught is common, so F1 we will take it common, so it is present in all the terms. The value 1 by 4 pi epsilon naught is present in all the terms, so we'll take it common. So 1 by 4 pi epsilon naught, here what is remain, Q1 Q2 by R12 square R12 cap plus Q1 Q3 R13 square R13 cap plus plus Q1 Qn R1n square R1n cap. So here also we have seen that the value Q1 is present in all the terms, so again we will take that value also common. So F1 will be equal to Q1 by 4 pi epsilon naught, then here only Q2 remaining by R12 square R12 cap plus Q3 remaining R13 square R13 cap plus plus Qn remaining R1n square R1n cap. So here we will write it in terms of summation, so it will be Q1 by 4 pi epsilon naught. Here we will write summation. The value is I will be equal from 2 up to n, so it will be here Qi, and here it will be R1I square R1I cap. Name this as equation number 4. So equation 4 is the required equation. So equation 4 is the required equation. It gives the force F1 which is acting on charge Q1, force F1 on charge Q1 due to multiple charges Q2, Q3 up to Qn. With this we complete the topic today. Thank you.